So we are going to look at exceptions in Java today. In the previous classes, we saw a glimpse of what are exceptions. Now we'll look at this topic in detail. So what are exceptions? Basically, what are runtime exceptions? Exceptions that occur when your program is running, not compile time. And how do we handle all those exceptions? So what is an exception? So exception is an error condition that changes the normal flow of control in a program. What does it mean? Means that, let's say we have written a program to divide two numbers. Simplest of the examples, right? And we are dividing a by b, but when we divide a by 0, that is not valid, right? So Java will give you a runtime error saying, hey, listen, divide by 0 is not allowed. So exceptions in Java separates error handling from main business logic. So exceptions help us to take care of such scenarios where we might be doing a wrong operation. Okay. Generally, when we do a wrong operation, what happens? The program terminates, right? The program terminates. So we don't want that behavior. We don't want the program to terminate. So we take care of the exception and then we continue with the normal flow of the program. So this is based on the idea developed in Ada, Eiffel and C++. These are all programming languages. And Java has a uniform approach for handling all synchronous errors. So what are synchronous errors? Synchronous is something that is executed line by line, right? So and it waits for every command to execute and then continue. So Java has this following approach for handling all uniform exceptions. Okay. So from very unusual example out of memory to common ones like index out of bound. We've seen all these examples, right? And there are also runtime errors such as divide by 0, right? And there might be user defined exceptions as well, which are not allowed by the logic of the program. Example, while registering a number, while registering on Facebook, can you register with the same email ID again? Can you register with the same email ID again? The answer is no, right? You cannot register with the same email ID again. So that is when you get, hey, listen, you get an error. Hey, the user ID is already registered, right? So that is Facebook throwing an exception for you. Okay. So in Java, we throw the errors and we catch them, right? So an error can be thrown as an exception, right? So error can be thrown as an exception. So by default, the exception results in a thread terminating after printing an error message, right? So as soon as there is an error in the program, we look at a program, probably an example program just now, it will be more clear. But as soon as there is an exception, there is an error in the program, what happens? By default, that program will stop executing, right? But if we can catch that error, do something about it, and continue with the normal program flow. And for that, what do we use? We use the try catch block. We use the try catch block. So how does it work? Creates a subclass of exceptions with an exception. So my class exception extends exception, right? Class my class, oops, there's a method oops in the class. It says if no error occurred, continue, otherwise throw an exception. Otherwise throw an exception, right? So exception basically breaks the normal flow of control, right? When an exception occurs, the statement will normally execute next is not executed. We'll look at this now. What happens instead depends on the whether the exception is caught, where it is caught, and what statements are executed in the catch block, and whether you have a finally block, right? So let's look at all these things. What are these? Let's remove all this. Wasn't exceptions covered last time? Yes, exceptions was covered, right? We have to do IO today. Okay, my bad. The second stream is called binary stream. What is binary stream? For now, think of binary stream as something which the computer directly understands, which a processor or a computer directly understands. So binary streams contains information encoded in a 8-bit information, right? So this is one letter, this is one letter, this is one letter, right? So for every character, we have a binary 8-bit binary information. Right? So either the program can write directly using the text stream which contains character to the device, or it can use the binary stream. It can use the binary stream. So streams in Java are objects, right? And they have two types of streams, right? Text stream or binary stream. And they also have two directions, right? It's very simple to remember. If think of it like this. So in Java, all the Java stream objects have there are two types of streams. There are two types of streams, right? One being text, one being text, the other being binary. And there are two directions associated. Either we can take an input or we can give an output, right? So this results in four base classes, right? So what are the four base classes dealing with IO? They would be reader class, which is text input, writer class, which is called text output, right? Then we have input stream that reads the byte input byte, that is the 8-bit information for a character, and the output stream which gives byte output, right? Is it clear? How do we map it? There are two types of stream, text and binary, and there are two directions associated with each stream. Got it? So in Java, eventually we have four combination of streams: text input, text output, byte input, byte output. I hope this makes sense. So for input stream, we have the following. We have the following classes. So input stream is an object. It has input stream. Input stream has the following subclasses: byte array input stream, file input stream, filter input stream, right? Then again filter input stream has a different set of classes, right? This is the whole class hierarchy for the different input, output and reader writer classes. Okay, so don't worry about it, we'll look at them. This is just an overview. Like a writer class has a buffered writer, a char array writer, filter writer, or a pipe writer, string writer, print writer, right? So it's just an overview. With the Java provides you with so many different classes which can read and write data in a different ways according to your requirement. So let's say if I know I just want to read a character at a time, or I want to write a character at a time, so I can use the character array writer, right? Similarly, if I want to read, right, I can use a array array reader or a buffered reader. What is a buffer? Buffer collects a lot of buffer collects a lot of information and writes it at once, right? Then we have stream tokenizer, which tokenizes the stream that is coming in, right? We saw a tokenizer class, string tokenizer class we saw in the previous classes. What did it do? It broke the string into different tokens. different tokens. So input stream, output stream, reader, writer are abstract classes, right? They are abstract classes. So what is the purpose? They can be sub-classified at two different characteristics of source destination. For final device, that is data sync stream, purpose serve as the source destination stream. This stream really write or read. For intermediate process, right, means as in if they act as an intermediate process, the alter the manage the information on the stream, right? What are they trying to say is, so if we are writing directly to the final device using them, right, so then they can serve as a source and destination, right? The streams write or read. But if we are using them as an intermediate class, which we'll see in an example just a little ahead, they alter or manage the information in the stream, right? They alter the manage the information in the stream. So input output journal scheme, what do we have? What is the journal process? Reading. So we open an input stream. While there is more information, we read data from the stream and then we close the stream. So we have to follow three processes. What are those? Open an input output stream. While there is more information, read data from the stream and eventually close the stream, right? In Java, what do we do? So first we create a stream object and associate a disk file with it. So where are we going to read or write to? Now we give that stream the desired functionality, right? We give that stream the desired functionality. We look at what the functionality is. While there is more information, we read data from the stream and then we close the stream, right? So what do we do? We create a stream object, associate a file with it. We give the stream object the functionality. What is this functionality? We look in the next slides. Then we read data from the stream and then eventually we close the stream. So let's look at it. So we have a class called file writer. We have a class called file writer. So what are the different methods associated with this file writer class? Close, which closes the stream. Flush. So whatever is left in the stream, it will be flushed to the file. Write, for writing a character, array of characters. Writing the portion of the array. Write C, writing a single character. Write string, we can write a complete string or we can write a portion of the string, right? So what are these methods? If you look at them, what are these methods? We have the following methods. The first one is in the file writer class. What are these methods? The first method is close. It is used to close the stream. Then we have flush. It is used for flushing the stream. Write. You can write the array of characters or write character in a portion, and this method is abstract. So we have to write the logic. We have to write the logic for this, right? Then we have writing a single character, and then eventually we have write string, writing the complete string, and then writing a portion of the string, right? So text file class has the following methods. So how do we write text files? We use file writer, right? We use file writer. It's not very convenient. Only string output is possible. It's not efficient as well. Why? Because every character is written in a single step, right? And then there is a huge overhead. So what do? We wrap file better with processing streams. And what are those processing streams? They are buffered writer and print writer, right? We said that we'll use something else with the file writer class. right? So what do? We use buffered writer and print writers. What does that mean? Let's look at an example. So what do? We open the file writer class, associate a file with it, right? And we say, hey, we'll use a buffered writer with this class. Now what does a buffered writer do? It does not immediately go and write it to the file. It accumulates, creates a buffer, and once the buffer is large enough, it will then go and write it to the file. Then we enclose it with the print writer, right? We enclose it with the print writer, and then we say print writer B, right? We say print writer B, and then we simply output the file, write it to the file. That is how p.println I am a sentence in a text file. I am a sentence in a text file, and we say p dot close. We say p dot close. Let's look at the example. Where are all these files included? In the IO package. So we are going to write to a file using file writer, buffered writer, and print writer. So we simply say file writer f is equal to new file writer. Let's say a simple file, output.txt. Then we associate a buffered writer with this, and we enclose our file writer in the buffered writer, and then we say print writer, and we enclose our print writer in the buffered writer, and we just simply say p dot println, p dot println. This is a text. This will be written to the file. This will be written to the file. P dot close. P dot close. Let's save it. How do we say it? What should be the name of this file? Right, example. So let's compile it. How do we compile it? Right, example .java.txt. Okay, just let me move it. Yeah, let's compile it now. Cannot find symbol file writer. Hmm. So it says, hey, there's an unreported exception. IO exception must be caught and declared. So what happened? We did not catch the exception. So Java is very strict about IO exception. So what do we need to know? We need to wrap it into a try catch block saying IO exception. Error occurred, could not write to a file. Right? Now let's run it again. Compiled. Now let's run this program. Done. Now what happened? Was there a file created? Yes. And what is in the file? This will be written to the file. Isn't this what was you writing in the file? This will be written to the file. Right? We were writing this to the file. It appeared. Are there any doubts? Please go through it and let me know if there are any doubts. Gautami College. Pause here for a couple of seconds. Please go through it and let me know if there are any doubts. So all the colleges are offline. I'll pause the recording here. We'll resume after the colleges join.